Welcome to GATE ESE lecture. We are in lecture number 68 of ETC. Now this is our fourth module, that is your optoelectronic devices. Now we are in the chapter photodiode. Now this is the last video lecture for photodiode. Here we are going to discuss about a very simple question, and also we're going to discuss about photodiode ka couple of note points. Okay, now before get started, I want to tell you the symbol of the photodiode. There is in some book it represents like this, and also in some book it also represented as like this, photodiode. Okay, now sir, इस वाला क्या है, ये वाला ग्राफ क्या है, ये वाला डायग्राम क्या है? This is a diagram for LED, light emitting diode, and this is the diagram for photodiode. I want you to have clarity on this. In the next video lecture, we will going to start with pin photodiode. Okay, pin photodiode. There will be I think 2 video lecture, which consists of 2 video lecture. Okay, 2 video lecture. Every video lecture will be of 10 minutes of length. So there will be a 20 minutes of time. Within 20 minutes of time, I'll finish each and every concept which are associated with pin photodiode. Then after this, we'll get into LED subject. Okay, this is a very interesting subject. Huh? This is going to be like आपको बहुत पसंद आने वाला है LED वाला subject. Okay, now let's without wasting any time, let's get into the question that we're going to discuss here. Listen to this carefully. He's saying कि simple question है, like if photodiode is connected with this resistor of 100 ohm, and they both are connected with or get supplied through a voltage, that is your 0.4 volt voltage. Now he's asking, find the resistance offered by the photodiode. This photodiode, it must have some internal resistance of small r, correct? Now we need to find out the resistance offered by this photodiode, and along with that, we are also going to analyze if your illumination means intensity. Illumination means intensity. Now if I'm doubling the illumination, find the resistance offered by this photodiode. Now if you, in the second case, if you double the illumination, and what happens to this resistance value? It's a simple conclusion. See, अगर हम लोग intensity increase करते हैं, what happens if you increase the intensity? Obviously we saw in that graph na, if you this is at your normal intensity. Now if you increase the intensity, your current value is increasing. This is your current versus V voltage graph. Again, if you increase the intensity, your current value is increasing. Now with increase in intensity, now the thing is that why current is increased? Because current तभी increase करता है when your resistance value decreases. जब resistance decrease हुआ रहता है, that is how your current is improving ना. So we can say, so if you are doubling the illumination, obviously the resistance value will be decreased. Now I'm going to explain this thing to you through this question. There will be small clarity on this. Also we're going to discuss about small 2 to 3 note points. Now let's see this carefully. In the first case, our intensity is INT. So if you apply V equal to IR, V is given 0.4. So our current value is given 1.2 milliampere. It was your initial current value, and in place of R, I put here R plus 100 because both are in series condition, right? So R is equals to 233.3 ohm. Also here, if you look here, intensity became from normal INT to 2 into INT. Now what happened here? Intensity increases, sir, due to which, sir, your charge density is also increased. Charge density is also increased. That means your charge per unit volume increased. Absolutely correct. So ये कहाँ पे increase होता है, sir? Depletion layer में, sir. Photodiode का depletion layer में increase होता है, sir. Absolutely correct. That is why my current values also gets affected. That is, it got increased to some amount. Now I can say from this two relation, intensity is directly proportional to current. So INT1 by INT1 by I1 is equals to nothing but INT2 by I2. Now INT1 is nothing but 2 into INT1, correct? That is what it changes to in the second case, right? Now if you solve this equation, I1 is given your 1.2 milliampere, and I2 I need to find out. Now this 2 will be cancelled out, correct? Now if you this is also given, this is given. Now if you want to calculate the I2 value, the I2 will come out to be, in the second case with increased photo illumination case, you'll get this value, right? Now if you put we know we have V is given 0.4, and if you put in place of V the 0.4 value, and in place of I2 in place of R, if you put 100 plus R, then you can get the in place of I2 you're going to put the value that is nothing but 2 into 1.2 into 10 to the power minus 3. Now here you can get the changed resistance value. Now here I can say, in the first case when my intensity was INT, the resistance of the photodiode was used to be 233.3 ohm. Now when my intensity increased to some extent, my resistance got changed to 66.6. So here we can say with increase in intensity, my resistance is decreasing. Now that is what I am going to explain you through couple of note points. Here I am going to discuss with you 3 note points. Now start with the first note point. With increase in intensity value, photodiode resistance is decreasing. Correct. That is what we saw in the previous case. Always remember this thing, because my current value is improving now. With increasing intensity my current value is improving, that is why my photodiode resistance decreases. Okay, here is a very simple point. Most of you people must have this kind of doubt ki sir, why we can't use this forward bias case? In case of forward bias case, the photodiode, because look here carefully, if any interviewer asks you why we can't do the analysis in case of forward bias case. In case of reverse bias, your depletion layer is more. Okay, that is why you'll have if you apply more and more amount of photons to your depletion layer, there will be chances of generation of electron and hole pair more and more. Electron hole, there will be more amount of generation of electron hole pair. There will be more and more amount of covalent bond breaking. But in case of forward bias case, your depletion layer is small. Correct, your depletion layer is very small. So in that case, there will be less generation of carriers, there will be less improvement. There will be improvement in current value, yes, but there will be less amount of improvement. Okay, so if any interview asks you this question, don't explain all these things. Just tell them forward biased PN junction is having less photosensitivity, but your reverse bias PN junction is higher photosensitivity. It has more photosensitive. It is more photosensitive. Okay, because there is a more and more amount of electron hole pair generation is there, and in case of forward bias case, your less amount of electron hole pair generation. Okay, always remember this thing. Lastly, I'd like to tell you one simple formula which is very much important for your engineering service and GATE. Obviously, when you are increasing photo intensity, photo illumination, if you are increasing it, your resistance, the photodiode resistance will be decreases. So I can say the circuit is about to short, the circuit is about to get into the zone of short circuiting, right? So the short circuited current, if there is IS and V became your open circuited voltage, now always remember these two formula. The total current, which will be nothing but IS plus I naught minus I naught into e to the power V by eta t. V equals to nothing but eta Vt ln 1 plus IS by I naught. Okay, remember this formula. This is very much important for your GATE and ESE exams. Okay, with this we are done with today's lecture. Thank you so much for your patience, and if you have any kind of question, feedback, query or suggestion for this video or this channel, feel free to write it down below in the comment box. And if you want more and more videos like this, give us a thumbs up and do subscribe to our channel GATE ESE Lectures. See you in the next lecture of pin diode. Okay, till then, bye.